Hello and welcome to the Sleepy Scientist. I am happy you found your way here tonight. Before we start, I would like to know where in the world you are listening from. You can tell me in the comments if you feel like sharing. If you are new to the channel, a soft tap on the like button and a quiet subscribe would mean a lot. It helps more sleepy minds find their way here. And if you are already subscribed, thank you. Your support is what keeps these slow talks going. I hope this video is not so interesting that it keeps you awake, but if it does, at least you will have something to think about while you wait for sleep. Tonight, as the world outside becomes still, we will explore a question as big as the sky itself. Can we really understand how big the universe is? We say things are big all the time: a big tree, a big city, a big mistake. The word is easy to say, so is far, or even endless. But most of the time we are not really picturing anything close to the real thing. Not when it comes to the universe. The truth is our minds were not made for this kind of size. They evolved to see how far the next branch is or how large an animal looks in the distance, maybe a few kilometers. That is the size we are used to, the normal, the easy to handle. But out there past our planet, distances go into millions, then billions, then numbers that laugh at our ability to imagine. In this video, we will take a slow trip outward from the ground under your feet to the edge of the known universe. We will pass planets and stars, move through galaxies and cosmic webs, and drift into places where science turns into philosophy and space turns into poetry. This is not a search for hard answers. There may not be any. Think of this as a calm float through huge space, a way to sit with the biggest questions and feel their light beauty. Because sometimes the most human thing is not to understand the universe, but to be amazed that we can wonder about it at all. When you think about distance, what do you imagine? Maybe walking across the street, driving to the next town, or flying across the ocean. We understand these sizes because they fit in our daily life. A meter, a kilometer, these are things we can see and feel. But once you leave Earth, those easy measures stop working. The universe does not play by the same rules. It is not just big, it is extremely big. And trying to measure the universe with Earth-sized tools is like trying to measure the Pacific Ocean with a teaspoon. Let's start with something close. The distance from Earth to the Moon is about 384,000 kilometers. That sounds big but still fits in our sense of scale. It is like flying around Earth almost 10 times. Now think about the distance from Earth to the Sun, about 150 million kilometers. That is so far that light, moving at the fastest speed anything can, takes more than 8 minutes to reach us. This number is so important that scientists gave it a name, 1 astronomical unit. It is a handy way to measure distances in our solar system. Mercury is about 0.4 astronomical units. Jupiter is around 5.2 and Neptune is nearly 30. These numbers make the size feel smaller for a while, but the moment we leave the solar system, even astronomical units stop working. The nearest star beyond our Sun is Proxima Centauri, a small red star just over 4 light-years away, in astronomical units. That is about 268,000, not a friendly number. You would need a very large spreadsheet. This is why we use the light year. A light year is not a time, it is a distance. It is how far light travels in 1 year. Light moves at about 300,000 kilometers every second, so in 1 year it travels almost 10 trillion kilometers. That is 1 light year. When we say Proxima Centauri is over 4 light-years away, it means the light we see from it tonight left more than 4 years ago. If it exploded right now, do not worry, it will not. We would only know 4 years later. In this way, the light year is not just a ruler, it is also a time machine. Every time we look into the night sky, we are not seeing the universe as it is, we are seeing it as it was. The farther away something is, the older the light we get. We are not just seeing space, we are seeing history run in reverse. For people who are curious or brave with numbers, there is another unit astronomers use, the parsec. 1 parsec is about 3.26 light-years. It comes from a clever bit of math using how nearby stars seem to move against the background as Earth goes around the Sun. It is useful for some calculations, but if you just want to feel the size, light years are easier to picture. Still, no matter which unit we use, kilometers, AU, light years, or parsecs, we run into the same problem. The numbers get too big to really imagine. You can say billions of kilometers or millions of light years all you want, but those numbers slide through the mind without any weight. Our brains grew in a world where the farthest view was maybe a few dozen kilometers, where walking a couple of miles was a trip. No wonder numbers like 100,000 light-years, the width of our galaxy, or 13.8 billion light-years, the age of the observable universe, feel more like poetry than reality. This is why these space rulers matter. They help us push the limits of what we can think about. They give us a way to touch the unthinkable. They make a small bridge between our tiny world and the vast space beyond. It is almost comforting to know that even though we cannot walk a light year or touch an AU, we can still talk about them, think about them, and try to understand them, and maybe in the end, that is the real purpose, not to bring the universe to our size, but to stretch ourselves just enough to brush the stars. The universe has a speed limit and it is not open for debate, no matter who you are, how much fuel you burn, or how determined you are. You cannot go faster than light. In the quiet courtroom of physics, the speed of light is the final decision. Light moves at just under 300,000 kilometers per second. That is fast enough to circle Earth 7 times in 1 second. It is the fastest anything can go. Not only is it quick, it is basic to the laws of the universe. Even Einstein's famous equation E=mc² uses it. The c in that equation is the speed of light. It is more than just a number, it is built into reality itself. Because light moves so fast and so steadily, We use it to measure huge distances, but when we do, something strange happens. Time and space start to mix together. In daily life, time and distance are separate. You can walk 5 kilometers in an hour or drive it in 5 minutes. But in space, those lines blur. When we say something is 1 light year away, we mean it is so far that light takes 1 year. To get here, that distance is about 10 trillion kilometers, but since we are using time to measure distance, we are really talking about both. You cannot say how far without saying how long. This is where the speed of light plays tricks on our sense of time. When you look at the moon, you are seeing it as it was just over 1 second ago. That is how long light took to reach you. The sun is farther, about 8 minutes by light. So the sunlight that warms you this afternoon left the sun when you were still brushing your teeth. Now look farther. The light from Sirius, the brightest star in the night sky, took about 8.5 years to get here, from the Andromeda galaxy, over 2.5 million years. You are seeing Andromeda not as it is now, but as it was before modern humans walked the earth. Every star you see is an echo from the past. Space is not a backdrop. It is a time machine. Light brings us postcards from far away. But they are never current. They are always late, sometimes by billions of years. This means telescopes are also time machines. The deeper they look, the older the light they catch. Astronomers have seen galaxies whose light has traveled for more than 13 billion years. These are views of a young universe, long before our sun or planet existed. The speed of light forces us to think in 4 dimensions, not just where something is, but when it is, because light cannot outrun time. It carries memories forward, 1 second at a time. Now imagine this: if the sun somehow vanished right this second, not faded or dimmed but disappeared, we would not know for over 8 minutes. In that time the sky would stay bright and life would go on as if nothing happened, because the last photons from the sun would still be on their way, speeding toward us at the only speed they know. This is true for everything we see. Our eyes do not see the present, they see delayed images from the past. The farther we look, the older the view. There is no such thing as seeing the now of the cosmos. The present is only for what is near. This also means space has no universal now. Ask 2 observers moving at different speeds or in different gravity what time it is, and you will get 2 different answers. The speed of light ties time to the observer. In space, simultaneity does not really exist. Everything moves. Everything is relative. For humans this feels strange. We like our clocks to match. We like events to happen in order, but light does not care about that. It moves through space the way time moves in a dream, stretched and flowing. Even with all this, the speed of light is comforting. It never changes. It never gets tired. It does not bend rules. No matter where you are or how fast you go, you measure the same light speed. It is the universe's universal truth, a glowing thread linking every galaxy, every planet, every moment. It is also what makes the night sky so special. when you look at the stars, you are looking into history. A billion glowing memories across the dark, whether that light took seconds or billions of years to arrive, it all followed the same rule. The speed of light does not just limit us, it connects us, from one side of the universe to the other, through the oldest times. It carries the stories of everything that has ever shone, and tonight, some of those stories have reached you. If you ask someone how big the solar system is, they might picture planets lined up like beads: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, a neat family circling the Sun. But that view is misleading. The solar system is mostly empty space between planets. Let's start close. The Moon orbits Earth about 384,000 kilometers away. That is enough to fit every planet between the two with room to spare, and yet it feels close. We can see the Moon, follow its glow, and even send astronauts there. In space terms, it is our backyard. Now the Earth-Sun distance is about 150 million kilometers, 400 times farther than the Moon. It is so iconic it has its own name, 1 astronomical unit. If you could drive to the Sun at 100 kilometers per hour, it would take over 170 years without stopping. Even Mercury, the closest planet to the Sun, is about 1/3 of an AU away. Venus is 2/3, Earth is 1, Mars is 1.5. After that, the gaps grow. Jupiter is more than 5 AU. Saturn is almost 10, and Neptune is over 30. Between each planet is huge empty space. If the Sun were a basketball at the center of a football field, Earth would be a peppercorn 25 meters away. Neptune would be a marble near the far edge, and between them nothing but empty seats. The solar system looks crowded in drawings but is really like a desert with a few cactuses. Even the asteroid belt, imagined as a busy junkyard, is mostly empty. Standing on an asteroid, you might see nothing else nearby. Maybe a single dot far away, maybe nothing. But Neptune is not the end. Beyond lies the Kuiper Belt, a cold ring of icy debris. From 30 to 50 Australian dollars, this is where Pluto lives with other dwarf planets, and beyond that is the Oort cloud. So far we have never seen it directly. It may extend to 100,000 Australian dollars from the Sun, over 1.5 light years. The Sun's gravity may reach halfway to the nearest star, but out there space is slow, empty, and weak. To get a real sense of the size, think about the Voyager probes. Voyager 1 and Voyager 2 were launched in the late 1970s to study the outer planets. After finishing that job, they kept going. Voyager 1 is now over 150 Australian dollars from the Sun. It is the farthest human-made object ever. Yet even after more than 40 years of travel at over 60,000 kilometers per hour, it has not reached the Oort cloud. It will take a few hundred more years to get there and tens of thousands to pass through. In a way, Voyager is our message in a bottle, a tiny piece of Earth sailing into the dark carrying sounds and images from our world. It shows how far we have gone and how much farther there is. All of this, the planets, belts, comets, and probes, is still just our local area. The solar system, huge as it is only a small bubble around one star in a galaxy with hundreds of billions more. It is humbling to know that even in our own star's space, distances are so vast we can barely imagine them, and yet we have measured them, mapped them, and sent machines to the edge. The solar system is defined not just by the sun or the planets, but by the empty space between, a space full of silence yet also motion, planets orbiting, comets returning, light streaming out in every direction. Even emptiness has rhythm. So how big is the solar system really? It is as big as everything we have launched, everything we have found, and everything we have yet to reach, and the farther we go, the more we see we have only just begun. The sun feels permanent, rising and setting, warming and lighting our days. It feels close and friendly, but when we talk about the next nearest stars, that comfort disappears. Space becomes very empty. The closest star to the Sun is Proxima Centauri, part of the Alpha Centauri system. 3 stars bound by gravity, Alpha Centauri A and B, are like the Sun, and Proxima Centauri is a small red dwarf far from them. Even though Proxima is the nearest star, it is still over 4 light years away. That is more than 40 trillion kilometers, so large it almost means nothing, for light years sounds possible until you remember what a light year is. Light takes over 4 years to travel that far. Voyager 1, moving at more than 60,000 kilometers per hour, would take over 70,000 years to reach it. And that is just the nearest star. If you scaled the solar system so the Sun was a marble, Earth would be a speck a meter away, Neptune would be 30 meters away. On that scale, Proxima Centauri would be another marble over 8 kilometers away, and in between there would be nothing but empty space. This emptiness is what makes travel between stars so hard. Even our best engines struggle to reach other planets, so going to another star needs technology we do not yet have. Science fiction loves warp drives, hyperspace, and wormholes, but in reality, we have not even sent a probe to another star system. There are ideas like Breakthrough Starshot, using powerful lasers to send tiny spacecraft to Alpha Centauri at up to 20% of light speed. They could make the trip in just over 20 years, but building and aiming such craft is still a dream. The truth is the universe is mostly nothing. Stars are spread like lanterns in endless fog. The Milky Way has hundreds of billions of stars, but the average distance between them is about 5 light years, a lot of black space between each light. Let's picture it in a simple way. Imagine a huge field stretching for kilometers in every direction. In this field you place 1 grain of salt to represent the Sun, then you walk 8 kilometers in a straight line and place another grain of salt to represent Proxima Centauri. If you keep doing this in all directions, you will start to understand how empty space really is. It would be like a galaxy of salt floating in an endless sea of nothing. Even these tiny grains, the stars, are massive and powerful. Proxima Centauri may be small and dim compared to other stars, but it is still about 130 times the mass of Earth. The Sun is over 300,000 times the mass of Earth. Each star is a giant engine of fusion burning for billions of years, yet for all their brilliance, they remain small points of light in a vast invisible space. The emptiness between stars is not just about distance. It is also about energy and time. Traveling between them requires more than just movement, it needs survival. In the deep void, protection from dangerous radiation, and a way to communicate across decades or centuries, and even if you arrive, there is no promise that the world you find will be welcoming or even solid. That is why astronomers are so focused on studying planets around other stars. If there is another Earth-like planet around Proxima Centauri or Alpha Centauri A or B, it would be one of the greatest discoveries in human history. But even if such a planet exists, getting there is a completely different challenge. Still, we keep trying, we keep measuring, imagining, and planning. The stars may be far, but they are never beyond our curiosity. We may not reach them with rockets soon, but we can already reach them with our thoughts. That is the strange thing about space. Physically, the stars are far beyond our touch, but in our minds they are already close, already a part of our human story. And maybe that is enough for now, to know that far away, more than 40 trillion kilometers from us, another star is shining in our direction. Its light, dim and red, is already here, arriving quietly, reminding us that even in the deep empty space between stars, we are not completely alone. If you have ever looked up and seen a faint milky band stretching across the night sky, you have already seen a small glimpse of something massive, our home galaxy, the Milky Way, from Earth. It looks like a hazy band made of countless stars too far away to see individually, but that faint glow is actually part of a huge spiral galaxy with hundreds of billions of stars, all held together by gravity and slowly spinning through space. The Milky Way is shaped like a giant flattened disk with a bulge in the center. Imagine a cosmic frisbee about 100,000 light-years wide and about 1,000 light-years thick. Even light, the fastest thing in existence, would take 100,000 years to travel from one side to the other. Somewhere in that spinning whirlpool of stars is our Sun, our solar system, and everything we have ever known. But we are not near the busy center. We live in one of the quieter outer regions, about 27,000 light-years from the core. Our solar system sits in a smaller spiral arm called the Orion Arm, which lies between two larger arms, the Sagittarius and Perseus arms. If the Milky Way were a giant pinwheel, we would be between the middle and the edge, moving calmly around the center. It is not a special location, no galactic city center, but it is quiet and stable, which might be one of the reasons life had time to grow here. Even though we are far from the center, we are not standing still. the whole solar system is moving along with the galaxy's rotation. Right now, our Sun is orbiting the galactic center at about 828,000 kilometers per hour, which is fast enough to circle the Earth more than 20 times in a single hour. But the galaxy is so huge that one orbit, called a galactic year, takes about 225 million years, the last time our solar system was in this same place in the galaxy. Dinosaurs were just beginning to appear on Earth. Since the Sun was born about 4 billion years ago, it has only made about 20 trips around the galaxy's center. 20 laps in over 4 billion years shows just how huge the Milky Way really is, and even though everything in it is moving, the stars in the night sky do not seem to change much during a human lifetime. From our short viewpoint, the stars look still, but they are not. If you could watch a time-lapse over millions of years, you would see stars swirling like fireflies in a slow, graceful dance, tracing the spiral arms as they orbit. The center of the Milky Way is very different from where we are. There, stars are packed close together, orbiting a massive and mysterious object, a supermassive black hole called Sagittarius A*. It has the mass of about 4 million suns and sits quietly at the galaxy's core. We cannot see it directly, but we can watch how its gravity pulls nearby stars into fast, tight orbits. Out here in the Orion Arm, things are calmer. Stars are more spread out. Planets can orbit without much disturbance, and life has time to grow. Almost everything you can see in the night sky with your bare eyes, every star you have ever wished on, is within just a few thousand light-years of Earth. That is only a tiny part of the Milky Way's full size. Most of the galaxy is hidden by distance, dust, or faint light, yet we know it is there. Telescopes that see in radio and infrared have mapped its spiral arms, tracked the movement of its stars, and even revealed the invisible halo of dark matter around it. It is easy to think of the galaxy as just a pretty backdrop, but it is our island in the cosmic ocean. It is the only galaxy we have ever known from the inside. Every single thing humans have ever done has happened on a small planet circling a star that is quietly orbiting this massive spiral, and we are still moving, still riding the spiral, drifting around the center like leaves in a slow current, no matter how still the night may seem. We are traveling through the galaxy at hundreds of thousands of kilometers per hour, on a journey billions of years long. That is our place in the Milky Way, not central, not the most special, but still part of something ancient and beautiful, spinning in the dark. When we look at the night sky, it may seem like stars are scattered randomly, but often they are born together in groups, sharing the same cloud of gas and dust and bound by gravity. These groups come in different forms and tell us about how stars live and die. One type is the open cluster, a loose group of stars, maybe a few hundred or a few thousand, born from the same giant cloud. They are young, often just a few million to a few billion years old, still loosely held together by gravity. Open clusters are like star nurseries. One famous example is the Pleiades, also called the Seven Sisters. On a clear night you can see them without a telescope, a tight group of shimmering stars in the constellation Taurus. They are only about 100 million years old and still shine bright blue. Then there are globular clusters, very different from open clusters. These are dense spherical groups of hundreds of thousands or even millions of stars. They are ancient, some over 12 billion years old, orbiting the Milky Way outside its main disk. Stars are so close in these clusters that a single telescope image might show thousands of points of light packed into one sphere. One famous globular cluster is M13, the Great Hercules Cluster, about 25,000 light-years away with over 300,000 stars. If you lived on a planet there, your night sky would be bright with starlight, far more crowded than what we see from Earth. Globular clusters are like time capsules, holding some of the oldest stars in the galaxy. Their age tells us they formed when the Milky Way itself was young, long before the Sun or Earth existed. Unlike open clusters, globular clusters are stable for billions of years because their stars are bound tightly by gravity. They move as a group around the galaxy, far above and below its main disk. Sometimes they pass through the disk, but they spend most of their time in the galaxy's outer halo. Studying them helps scientists understand how the Milky Way grew and evolved. They may even be leftover cores of smaller galaxies that merged with ours in the distant past. Not all stars stay in clusters. Many are born in groups but later drift apart as gravity weakens. Stars that share a common birthplace can spread across great distances while still carrying clues about their origins. Astronomers can spot these stellar families by their motion and chemical makeup. This is how we learn the history of our part of the galaxy. Not all stars are the same. They come in a range of sizes, colors, and lifespans. A star's mass is the key to its life story. Massive stars burn bright and hot but die young, lasting only a few million years before ending in powerful explosions called supernovae. Smaller stars like our Sun burn steadily for billions of years, and very small stars, called red dwarfs, can burn for trillions of years, outliving the universe as we know it. Our Sun is a yellow dwarf star. About halfway through its 10 billion-year life, it has been shining for about 4.6 billion years and has enough fuel for another 5 billion or so. Stars shine because of nuclear fusion, in which hydrogen atoms are forced together under extreme pressure and heat to make helium. This process releases enormous amounts of energy, which travels from the star's core to its surface and out into space as light and heat. Fusion is what makes stars glow, keeping planets warm and allowing life to exist. Over time, a star changes. When it runs out of hydrogen in its core, the balance between gravity pulling in and pressure pushing out shifts. The star swells into a red giant. In this phase, it can engulf nearby planets, eventually shedding its outer layers into space, leaving behind a hot, dense core called a white dwarf. White dwarfs slowly cool over billions of years, fading into darkness. Massive stars, however, have a far more dramatic end. After swelling into supergiants, their cores collapse under their own weight, triggering a supernova. The explosion blasts heavy elements into space, which later become part of new stars, planets, and even life. What remains after the blast can be a neutron star, incredibly dense and spinning rapidly, or if the star was massive enough, a black hole, a region where gravity is so strong that not even light can escape. These stellar deaths are not just endings. They are beginnings too. Every atom in our bodies heavier than hydrogen was made in a star long ago and sent into space by a supernova. We are literally made of stardust, connected to the galaxy in the most physical way possible. When we say we are made of stardust, it is not just poetry, it is science. The carbon in our cells, the calcium in our bones, the iron in our blood, all were created in the hearts of long-dead stars. Every breath we take carries atoms that were once inside a star billions of years ago. This cycle of birth, life, death, and rebirth is how the universe renews itself. Stars form, shine, and die. And from their ashes new stars and planets are born, carrying the building blocks of life. The Milky Way is a vast factory of stars, with regions where new ones are forming right now. These stellar nurseries are made of giant clouds of gas and dust, often called nebulae. Under the pull of gravity, parts of these clouds collapse, heating up until nuclear fusion ignites. A new star is born. Some nebulae are dark, hiding young stars inside, while others are bright, lit up by the energy of the newborn stars. The Orion Nebula is one of the most famous and can be seen with the naked eye from Earth. As a faint patch in Orion's sword, through a telescope, it reveals clouds of glowing gas shaped like cosmic waves. Another well-known nursery is the Eagle Nebula, home to the towering pillars of creation, massive columns of gas and dust where stars are forming inside. These nurseries are like cosmic cradles, but they are also turbulent. Young stars can produce strong winds of particles and radiation that blow away the surrounding gas, slowing or stopping more star formation nearby. Over millions of years, a nebula can scatter, leaving behind only the new stars and perhaps some planets. As stars are born and die across the galaxy, they shape its structure and chemical makeup. Over time, heavy elements from supernovae mix into the clouds that form the next generation of stars. Each new cycle enriches the galaxy with more complex ingredients, making planets and life more likely. Our own solar system formed about 4.6 billion years ago from such a cloud, seeded with elements made in earlier stars. This means our Sun is at least a second-generation star, and perhaps even third or fourth, carrying the history of countless stellar lives before it. The planets, asteroids, and comets around it are all part of this recycling of matter, and so are we. It is strange and humbling to think that the atoms making up your body have been part of many different stories. Some may have floated in deep space for billions of years, Others may have been inside a giant star, and all have traveled across unimaginable distances to end up here, forming you. Stars and planets are not evenly spread in the Milky Way, they gather into structures like spiral arms, which are waves of density moving through the galaxy. Stars form more easily in these arms because the gas and dust are denser there, giving gravity more to work with. The arms are not solid objects but patterns, like traffic jams in space. Stars move in and out of them over millions of years. Our Sun is currently passing through a minor arm, the Orion Arm, and in the far future it will drift into another region. The galaxy is in constant motion, yet from Earth, the stars seem eternal and unmoving. This illusion is a gift, letting us see the sky as a steady map for thousands of years. For most of human history, the night sky has been our calendar, compass, and storybook. Ancient civilizations tracked the stars to mark the seasons, guide travel, and connect their myths to the heavens. Patterns of stars, called constellations, became a way to remember and pass down knowledge. Even though constellations are just chance alignments of stars from our point of view, they have been a powerful tool for navigation and storytelling. Orion, with his bright belt of 3 stars, points the way to Sirius, the brightest star in the night sky. The Big Dipper can guide you to Polaris, the North Star, which has been a constant beacon for travelers in the Northern Hemisphere. The Southern Cross serves a similar role in the Southern Hemisphere. These patterns helped humans long before maps and GPS existed, but they also inspired wonder. Cultures across the world saw animals, heroes, and gods in the sky. The Greeks imagined Orion the hunter, the Egyptians linked Sirius to the flooding of the Nile, and Polynesian navigators used the stars to cross the vast Pacific Ocean. Even today, constellations connect us to the people who came before, but they are not fixed forever. Stars move, and over thousands of years the shapes will change. A future sky will have different patterns, and the constellations we know may vanish or turn into something new. Beyond the stars we see with our eyes, there is far more hidden. Much of the Milky Way is invisible to us in visible light. Because clouds of gas and dust block the view, but telescopes that see in infrared, radio, and X-rays reveal structures we cannot otherwise see. Radio telescopes map the cold gas between stars, infrared can pierce dust to see newborn stars, and X-rays show high-energy events like black holes feeding on matter. Each wavelength of light gives us a different view of the galaxy, like peeling back layers to see its full story. Some of the most interesting things in our galaxy are not stars at all, but the remnants of dead ones. A supernova remnant is a shell of gas and dust thrown into space by a massive star's explosion, glowing from the energy of the blast. The Crab Nebula is one famous example, the remains of a star that exploded in 1054 and was recorded by astronomers in China and the Middle East. At its center is a neutron star spinning 30 times per second, sending out pulses of radio waves and light. These remnants are cosmic recycling plants, spreading heavy elements into space to become part of future stars and planets. Another strange object is the pulsar, a type of neutron star that spins rapidly, shooting out beams of radiation like a lighthouse. If one of these beams sweeps across Earth, we see it as a regular pulse, some so precise they rival atomic clocks. Then there are black holes, the most extreme objects in the galaxy, born from the collapse of very massive stars. Their gravity is so strong that nothing, not even light, can escape once it passes the event horizon. While we cannot see a black hole directly, we can see its effects. Matter falling into it heats up and emits X-rays, and stars near it orbit in strange ways. Black holes can be small, just a few times the mass of the Sun, or supermassive, like the one at the Milky Way's center, with millions of solar masses. They are among the most mysterious and fascinating things in the universe, challenging our understanding of physics and time itself. Black holes might sound like cosmic destroyers, but they are also an important part of how galaxies work. The supermassive black hole at the Milky Way center, Sagittarius A*, is mostly quiet now, but in the past it may have been far more active, feeding on gas and sending out powerful jets of energy. Such activity can affect the formation of stars in the surrounding region, slowing it down or even stopping it for a time. Even small black holes can be part of binary systems, where a black hole and a star orbit each other. In these systems, the black hole can pull gas from its companion star, forming a glowing disk of hot matter. These X-ray binaries are among the brightest sources in the galaxy in high-energy light. Black holes, neutron stars, pulsars, and supernova remnants are all part of the galaxy's life cycle, showing how matter is recycled over billions of years. The Milky Way itself is not standing still in the larger universe. Our galaxy is moving through space, pulled by the gravity of nearby galaxies and large structures. We are part of the local group, a small cluster of galaxies including the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies. The local group spans about 10 million light-years across and is bound together by gravity. Even though the galaxies are far apart, they are slowly moving, and some are on paths that will bring them together. The most dramatic example is the Milky Way and Andromeda. They are heading toward each other at about 110 kilometers per second. In about 4 billion years, they will collide. At first, the galaxies will pass through each other, their stars rarely hitting because of the huge empty spaces between them, but their gravity will pull and twist them into new shapes. Over time, they will merge into a single larger galaxy, sometimes called Milkomeda. While this sounds violent, the vast distances mean that the Sun and its planets will likely survive, though their position in the new galaxy will change. Such mergers are common in the universe and are a major way galaxies grow. The local group itself is part of a much larger structure, the Virgo supercluster, which contains thousands of galaxies spread across over 100 million light-years. This supercluster is just one of many, and together they form an even larger web-like structure of filaments and voids on a cosmic scale. Galaxies gather along these filaments like beads on a string, with enormous empty spaces in between. This is the large-scale structure of the universe, and the Milky Way is just one small point in it. Looking out into the cosmos, we see that everything is connected by gravity, from planets and stars to galaxies and clusters, and yet, for all the vastness, the same physical laws apply everywhere. The light from a distant galaxy follows the same rules as the light from our sun. The gravity that holds the moon in orbit is the same force that shapes the motion of galaxy clusters. This unity is one of the most beautiful truths of science. The universe is vast beyond our ability to truly imagine, but it is also consistent and knowable, piece by piece. The more we study the universe, the more we realize that we are part of something far larger than ourselves, and yet made of the same ingredients as the most distant galaxies. The atoms in our bodies follow the same rules as those in a star billions of light-years away. This shared physics is what lets us understand the cosmos, even from our tiny corner. Our tools for studying it have grown more powerful. From early telescopes like Galileo's simple glass lenses to giant observatories on Earth and in space, the Hubble Space Telescope has shown us galaxies billions of light-years away, revealing the universe as it looked when it was young. New telescopes like the James Webb Space Telescope can look even farther and in different kinds of light, seeing the faint glow of the first galaxies and peering into dusty regions where stars are born. Every advance in technology brings new surprises. Sometimes we discover things we expected, like planets around other stars, and sometimes we find things that rewrite the textbooks, like mysterious fast radio bursts or stars heavier than we thought possible. Studying the universe is not just about looking outward, it is also about looking back in time, because light takes time to travel. Every image of a distant galaxy is a snapshot from the past. The farther away we look, the older the light we see. This means the universe is like a layered record of its own history, waiting for us to read it. The cosmic microwave background is the oldest light we can see, a faint glow from about 380,000 years after the Big Bang. It fills the sky in every direction and is a record of the moment the universe became transparent. Before that, the universe was a hot, dense fog of particles and light constantly colliding. As it expanded and cooled, atoms formed and light could finally travel freely. This ancient light has been stretched by the universe's expansion into microwaves, which we can detect with special instruments. It is one of the strongest pieces of evidence for the Big Bang, along with the expansion of galaxies and the abundance of light elements. It tells us that the universe had a beginning about 13.8 billion years ago. Since then, space itself has been expanding, carrying galaxies farther apart over time. This expansion is not slowing down but speeding up, driven by something we call dark energy. Dark energy makes up about 70% of the universe, yet we do not know what it is. We can measure its effects but not see or touch it. Alongside it is dark matter, which makes up about 27% of the universe. Unlike dark energy, dark matter does not push space apart, it pulls things together with gravity. We cannot see it directly because it does not emit or absorb light, but we know it is there because of how it affects the motion of stars and galaxies. Only about 5% of the universe is normal matter, the kind that makes up stars, planets, and people. This means most of the universe is made of things we cannot see, making the cosmos even more mysterious than it appears. It is strange to think that almost everything in the universe is invisible to us, yet its presence is felt everywhere. Dark matter forms a kind of cosmic skeleton, a hidden framework around which galaxies form and grow. Without it, the Milky Way and other galaxies could not hold together, because there would not be enough visible matter to create the gravity needed. Dark energy is even more mysterious, acting like a force that stretches space faster and faster. We do not yet know if it is a property of space itself, a new kind of energy field, or something even stranger. Understanding these unknowns is one of the greatest challenges in science. The fact that we can detect them at all shows how far our knowledge has come. Only a century ago, we did not even know the universe was expanding, and now we are mapping its structure on the largest scales. The expansion of the universe means that the more distant a galaxy is, the faster it appears to move away from us. This is not because the galaxies are flying through space, but because space itself is stretching, carrying them along, over extremely long times. This expansion will change the universe dramatically. Galaxies that are now visible will eventually slip beyond our cosmic horizon, their light unable to ever reach us. In the far future, the night sky may grow emptier as distant galaxies fade away, leaving only our local group bound together by gravity. But that is trillions of years from now. For now, we live in a time when the universe is rich with light and structure, when we can see billions of galaxies and trace their history. The Big Bang model gives us a broad outline of the universe's life so far, but many details remain to be filled in. How did the first stars form from the dark matter and gas? How did small galaxies merge into giants like the Milky Way? What role did supermassive black holes play in shaping them? These are questions astronomers are still working to answer. The search for answers takes us to the edge of what we can observe, to faint signals buried in noise, to experiments deep underground that try to detect particles of dark matter, and to massive simulations that recreate billions of years of cosmic history in a computer. Each discovery is a small step toward a bigger picture. The universe is not just vast in space. It is vast in time, spanning almost 14 billion years of history. Our own story, from the birth of the sun to the rise of life on Earth, is just a tiny fraction of that, yet we are able to look back to the very beginning and imagine the far future. This ability to understand, to piece together the story of everything, is one of the most remarkable things about being human. We are made of the universe, and the universe has given us the ability to know itself, even if only in part. For all we have learned, there is still more we do not know. Every answer in astronomy seems to open new questions. We can measure the age of the universe, yet we do not know what happened in the first fraction of a second after the Big Bang. We can see galaxies billions of light-years away, yet we do not know exactly how the first ones formed. We can detect planets around other stars, yet we do not know how common life is. The search for life beyond Earth is one of the most exciting parts of modern astronomy. Our own solar system has places that might once have been habitable, or might still hold life today. Mars shows signs of ancient rivers and lakes, and we are sending rovers to search for chemical clues. Beneath the icy crusts of moons like Europa and Enceladus, there may be oceans of liquid water kept warm by tidal forces from their parent planets. These oceans could be home to life, even without sunlight. On Titan, Saturn's largest moon, there are lakes and rivers of liquid methane and ethane, a chemistry completely different from Earth's. The idea that life could exist in such strange environments has expanded our thinking about where to look. Beyond the solar system, we now know of thousands of exoplanets, some in the habitable zone, where liquid water could exist. These discoveries come from clever methods like the transit method, where a planet passing in front of its star causes a tiny dip in brightness, or the radial velocity method, where the gravity of a planet makes its star wobble. A few exoplanets have even been photographed directly, though they appear only as faint dots next to their stars. The next step is to study their atmospheres, looking for gases like oxygen or methane that could be signs of life. Future telescopes may be able to detect these biosignatures on worlds dozens of light-years away, even if we find no clear signs. The search itself will teach us about how planets form and how rare or common Earth-like worlds might be. The discovery of life, even microbes, beyond Earth would be one of the most important moments in human history. It would mean we are not alone, that life is a cosmic phenomenon, not just a local accident. On the other hand, if we search for decades or centuries and find nothing, that too would be profound. It would suggest that life is rare, and that Earth is even more precious than we thought. Either way, the universe invites us to explore, to keep looking outward while also cherishing our own fragile world. We are lucky to be here in this brief moment of cosmic history, with the tools and curiosity to ask these questions. The search for life is not only about science, it is also about perspective. Finding even a hint of life elsewhere would change how we see ourselves. It would connect us to something bigger, showing that the spark of life can appear in more than one place in the universe. But until that happens, Earth is the only place we know that is alive. From space, our planet is a small blue and white sphere wrapped in thin clouds and atmosphere. A fragile home in a vast dark sea. Astronauts often speak of The overview effect, the shift in perspective they feel when seeing Earth from orbit, borders vanish, conflicts seem small, and the need to protect our world becomes clear. Our atmosphere is like the skin of an apple compared to the size of the planet, a delicate layer that makes life possible. Without it, Earth would be frozen and lifeless like the moon, or scorched and dry like Mercury. The balance of conditions here, temperature, air, water, and sunlight, has allowed life to flourish for billions of years, but this balance is not guaranteed forever. Over Earth's history, the climate has shifted, continents have moved, and species have risen and fallen. The dinosaurs ruled for over 150 million years before a sudden asteroid impact ended their reign, clearing the way for mammals and eventually humans. Today, humans are the first species to understand and measure the forces that shape the planet, and also the first capable of altering them on a global scale. Our technology can protect us from some threats, like predicting storms or tracking asteroids, but it can also create new dangers, like climate change, nuclear weapons, and habitat destruction. This makes our moment in history both powerful and fragile. We are part of the natural cycle, yet we are able to shape it. The same curiosity that drives us to explore the stars must also guide us in caring for our own world. The Earth is not separate from the cosmos, it is a product of it, formed from the same stardust as the planets, moons, and asteroids. Its oceans were likely delivered in part by icy comets, its land enriched by the heavy elements forged in ancient stars. Even life's basic ingredients, like amino acids, have been found on meteorites and in interstellar clouds. This means the seeds of life may be scattered throughout the galaxy, waiting for the right conditions to grow. Our planet's history is written in its rocks, ice, and fossils, but it is also written in us. Every cell carries a chemical memory of ancient oceans, every breath a mix of air shared with countless generations. When we explore space, we are also exploring our own origins, looking for the chapters of a story that began long before humans appeared. The urge to explore is not just about finding new places, it is about understanding who we are. The night sky that inspires poets and scientists alike is a reminder that we are both small and connected to something endless. Whether we find life out there or not, the journey itself matters. It teaches us to look beyond our daily struggles, to see our shared place in the universe, and to imagine futures we have not yet lived. One day, perhaps, humans or our descendants will walk on other worlds under alien suns. They will carry with them the memory of Earth, the knowledge that it was here, on this small blue planet, that their story began. If humans ever do travel to other worlds, it will be one of the greatest adventures in our history. The first steps beyond Earth have already been taken, with astronauts walking on the moon and robotic probes visiting every planet in our solar system. We have landed rovers on Mars, touched down on asteroids, and even flown through the atmosphere of Titan. Each mission expands our reach and our understanding. But traveling to other stars will require a leap in technology far beyond anything we have now. The distances are so great that even our fastest spacecraft would take tens of thousands of years to reach the nearest star. This means we will need new ways to travel, perhaps using powerful light sails driven by lasers, advanced fusion engines, or concepts we have not yet imagined. Some ideas sound like science fiction but are grounded in real physics, such as using antimatter for propulsion or bending space itself through a warp drive. These technologies are far from ready, but history shows that what seems impossible today can become reality with time and effort. In the meantime, we continue to send robotic explorers. They are our scouts, going where we cannot yet go, gathering data and sending it back across billions of kilometers. The Voyager probes, launched in the 1970s, are now in interstellar space, still transmitting faint signals. They carry with them the golden record, a message from Earth with sounds, images, and greetings in many languages, a time capsule. For anyone who might find it, this gesture reflects something deeply human, the desire to reach out, to connect, to say, "We were here," even if no one ever hears it. The act of sending it matters. Our exploration is not just about survival or resources, it is about curiosity and meaning. Space is vast, cold, and empty, but it also holds beauty beyond measure. Saturn's rings shimmering in sunlight, the icy plumes of Enceladus, the crimson deserts of Mars, the swirling storms of Jupiter, these places remind us that the universe is full of wonders we have only begun to see. In exploring them, we are not just learning about other worlds, we are learning about ourselves, what we value, and what we dream. Human exploration also faces challenges. Space is dangerous, with radiation, microgravity, and isolation posing serious risks to health and mind. Long missions will require not just advanced engineering but also deep psychological preparation. Communities in space will need to be self-sufficient, able to grow food, recycle air and water, and repair their own equipment. These challenges are not reasons to stop, they are problems to solve. Each step we take into space will make the next one easier, and the skills we develop there will help us on Earth too. Technologies for clean energy, recycling, and medicine often come from space research. The more we reach outward, the more we can improve life here at home. This is why exploration is worth the effort. It is an investment in our future, both in the stars and on the ground, and perhaps one day, people will look back on this time as the moment when humanity truly began its journey into the wider universe. The journey into the wider universe will not happen all at once. It will come in steps. Each generation will push a little farther, building on the work of those before. Just as the first sailors explored coastlines before crossing oceans, we are now exploring the shores of our cosmic neighborhood. The Moon and Mars are our first great goals. The Moon offers a nearby place to test new technologies and learn how to live and work on another world. Mars, though much harder to reach, holds the promise of a new frontier, with its ancient riverbeds and the possibility that it once had life. Building bases on these worlds will require using local resources, making fuel from Martian air, building shelters from lunar rock, growing food in controlled habitats. Each success will make the next mission easier and more ambitious. Beyond Mars, the outer planets and their moons offer mysteries waiting to be explored. Europa's icy shell hides an ocean that could be home to alien life, Titans. Thick atmosphere and methane lakes present a world unlike any other. These destinations are far, but robotic missions today are paving the way for human explorers tomorrow. As we travel farther, we will need new ways to protect ourselves from the hazards of deep space. Radiation from the sun and cosmic rays is a constant danger outside Earth's magnetic shield. Engineers are studying how to use water, metal, or even magnetic fields as protection. Artificial gravity, created by rotating spacecraft, may help prevent the muscle and bone loss caused by weightlessness. Space travel will also test our ability to live together in small communities for years at a time. Learning how to solve conflicts, share resources, and maintain mental health will be as important as building rockets. Over time, human presence in space could grow from small research outposts to permanent settlements. Linked together in a network across the solar system, these communities could exchange resources, knowledge, and culture, making humanity a multi-planet species. This shift would not only protect us from disasters on Earth but also expand the range of our dreams. A child born on Mars might grow up seeing Earth as a distant blue star in the sky, while still feeling connected to it through shared history. The stories of humanity would then stretch across worlds, linked by travel and communication. Eventually, the skills we learn in the solar system could prepare us for journeys to nearby stars. Even if such voyages take centuries, they could be made by ships carrying generations of people. With each new generation continuing the mission, the first explorers to another star may never see Earth again, but they will carry its memory, its languages, its art, and its science with them. In this way, exploration is not just about reaching new places, it is about carrying our humanity forward, ensuring that our stories, our knowledge, and our spirit of curiosity are never confined to a single world. The universe is vast, but step by step, we can make it a little less empty. Becoming a multi-planet species will change not only our future but also our identity. Right now, we think of ourselves as people of Earth, bound together by one home, but once humans live on the Moon, Mars, and beyond, our sense of belonging will expand. We will still share the same origins, but our environments, cultures, and even bodies may begin to change. People who grow up in lower gravity might be taller and have different bone structures. Communities living in enclosed habitats may develop unique customs, languages, and art. Just as Earth's continents shaped human history, The different worlds of the solar system will shape the lives of those who live there. Over centuries, these differences could become as great as those between ancient civilizations on Earth, yet the threads of connection will remain, through communication, trade, and shared challenges. One of the greatest challenges will be staying united as a species. Space will test our cooperation in ways we have never faced before. Disputes over resources, territory, or governance could arise, but they could also be solved with new systems of fairness and cooperation. Learning to live peacefully across planets might be the key to our survival. The story of humanity in space will not be just about science and technology. It will also be about values, the decisions we make, how we treat each other, how we care for the worlds we settle, and how we share knowledge, will define the legacy we leave. Space is not just empty land waiting to be used. Many places we visit will be beautiful and unique, untouched for billions of years. Standing on the surface of another world, seeing alien skies and landscapes, will remind us that we are visitors and stewards, not owners. This sense of respect will be important if we encounter life, even if it is just microbes in an alien ocean. The discovery of even the simplest life elsewhere would be one of the most important moments in history, forcing us to think about our place in the universe in a new way. Would we try to study and protect it, or would we risk harming it by settling nearby? These questions are not just theoretical. We must answer them before we go. Our choices will show what kind of explorers we are. As our presence in space grows, so will our ability to shape the future of life itself. We may learn to terraform planets, changing their atmospheres and surfaces to make them more Earth-like. This could give humanity new homes, but also comes with risks and responsibilities. Altering a world means changing its history forever. We will have to decide which worlds to leave untouched and which to transform. These are decisions that will echo for thousands of years, and they require wisdom as much as ambition. In the end, our journey into space will not only be about survival, discovery, or expansion. It will be about becoming the kind of species that deserves to explore the stars. Our future will be written not just in the places we reach, but in how we reach them, with curiosity, respect, and the knowledge that we are part of something far greater than ourselves. As we look to the stars, it is easy to imagine great ships, alien worlds, and vast colonies, but the first steps will likely be far more humble. Space exploration is a slow process of trial, error, and persistence, just as early explorers on Earth faced storms, shipwrecks, and years away from home. Space travelers will face dangers and setbacks. Rockets will fail, missions will be delayed, and unexpected problems will arise. But each challenge will teach us something new. Every mistake will shape better designs. Every small success will pave the way for larger ones. The International Space Station is a good example. It took decades of planning, cooperation between many nations, and thousands of launches to build and maintain. it shows that humans can live and work in space for long periods, growing food, conducting experiments, and learning how to adapt. Future space stations may orbit the Moon, Mars, or even asteroids, acting as hubs for exploration. These will be the stepping stones to more distant places. Our technology is already improving rapidly. Reusable rockets have cut launch costs, robotic landers can operate for years, and spacecraft are now exploring the outer edges of the solar system. Each new tool expands what is possible. The more we learn, the more ambitious our goals can become. In time, we may have fleets of robotic probes scouting dozens of worlds at once, sending back streams of data that reveal their landscapes, weather, and resources. Human missions will follow, bringing with them the ability to make decisions instantly, repair equipment, and explore more flexibly than robots alone. But no matter how advanced we become, space will remain dangerous. There will be accidents and losses, and the vast distances will always limit how quickly we can travel. Communication with even the nearest planets can take minutes, and with distant spacecraft, hours. This means explorers must be self-reliant, able to solve problems without immediate help from Earth. Over time, this independence will shape space communities into resilient, creative, and resourceful societies. These qualities may be what allow us to go beyond the solar system one day. Reaching another star will require patience on a scale we have never known. Missions could last centuries, passing from one generation to the next. The people who set out may never see their destination, but their descendants will. This kind of journey will test not just technology but human culture, requiring a shared purpose that can survive for lifetimes. It is a challenge unlike any in history, but also an opportunity to create a legacy that lasts for millennia. In many ways, exploring space is not just about escaping Earth. It is about ensuring that life itself can continue, even if our home world changes, whether through natural disaster or our own actions. Earth will not last forever. The sun will one day expand and make the planet uninhabitable, long after humans as we know them are gone. But if we have learned to live among the stars, our story can go on, carried by countless worlds and countless generations. Thinking on such long timescales can feel strange. Our daily lives are measured in hours and years, but the universe works in millions and billions. The idea that we could create a civilization lasting tens of thousands of years challenges the way we think about the future. It requires planning and cooperation on a scale that no human society has ever achieved. Yet the fact that we can imagine it at all is remarkable. We are the first species on Earth to understand the vastness of space and time, and the first to have the tools to begin such a journey. Our survival so far has depended on adapting to new challenges, from ice ages to resource shortages, and space will present the greatest challenges yet. The rewards, however, will be extraordinary. A species that learns to live beyond one planet is no longer bound by the fate of that planet. we will be able to explore and settle in many environments. From icy moons to warm ocean worlds, from rocky planets to massive space habitats. Built in orbit, each will require its own technologies, cultures, and ways of life, and over time these differences will make humanity richer and more diverse. The exchange of knowledge, art, and ideas between these worlds could create a civilization more creative and resilient than anything in history. We might one day look back at this era as the moment when everything changed. When humanity shifted from being an earthbound species to a spacefaring one, the transition will not be easy. It will require vision, patience, and the ability to think far beyond individual lifetimes. It will also require a balance between expansion and preservation. We must protect Earth as our first home, even as we explore others. Our planet is the only place we know for certain that life exists, and it is irreplaceable. No matter how far we travel, Earth will remain a place of origin, history, and meaning. A shared point of connection for all humans, future generations born on Mars or in deep space will still be linked to it, perhaps visiting as we now visit the lands of our ancestors, and just as we tell stories of the great explorers of the past, they will tell stories of the first people to cross the void between worlds. These stories will become part of a shared heritage that unites us, reminding us of where we came from and what we can achieve together. Space offers endless possibilities, but it also asks us to grow, not just in knowledge and skill, but in wisdom, if we can meet that challenge. The next chapters of our story will be greater than anything we have yet imagined. As humanity moves forward into this new era, our greatest tool will be our imagination. Every achievement in space exploration began as an idea in someone's mind, from the first rocket designs to the dream of landing on the moon. Imagination allows us to see beyond current limits, to picture worlds we have never visited and ships we have never built. It fuels innovation, inspiring scientists, engineers, and explorers to turn what seems impossible into reality, but imagination alone is not enough. It must be paired with knowledge, discipline, and cooperation. Space exploration is too vast for any one person or nation to accomplish alone. The International Space Station shows what is possible when countries work together, pooling resources and expertise for a common goal. Future missions to Mars or beyond will require even greater partnerships, uniting people from all over the world. Such cooperation could be one of the most valuable outcomes of exploring space, helping to reduce divisions and reminding us that we share one home, on Earth. Our differences often seem large, but from orbit, they vanish into a single blue sphere. That view changes people, giving them a sense of responsibility to protect our planet and each other. If space exploration can spread that perspective, it may help us solve problems here as well. Technology developed for space already improves life on Earth. Solar panels, medical devices, water purification systems, and communication tools all have roots in space research. As we push farther out, these benefits will grow. Creating habitats for other worlds could lead to breakthroughs in energy, recycling, and sustainable living that we can use here. The challenges of space will force us to think more creatively about using resources efficiently and reducing waste. Beyond the practical gains, there is also something deeply human about exploration. It connects us to our ancestors, who crossed oceans and continents driven by curiosity and the hope of something new. Space is the next ocean, vast and mysterious, with horizons that recede no matter how far we travel. Standing on a world under an alien sky, we will be part of a story that began long before us and will continue long after. The footprints we leave on other worlds will join the ones on the moon as markers of our journey, symbols of our ability to reach beyond our origins. They will say to anyone who comes after, human or otherwise, that we were here, that we looked up at the stars and dared to follow them. This is the legacy we can create, not just in technology and science, but in spirit, a reminder that the universe is not something we only observe from a distance. It is a place we belong to, a place we can touch, shape, and be part of. If we choose wisely, our steps into space will be the first lines of a chapter that never ends. The chapter that never ends will be written not only by astronauts and scientists but by countless ordinary people whose work and dreams make exploration possible. Every mission into space is built on the efforts of engineers, technicians, programmers, doctors, artists, and educators. Their contributions may not be as visible as a rocket launch, but they are just as essential. The path to the stars is paved by teamwork, with each skill and talent adding to the whole. This means that space exploration is not only for a select few. Anyone can be part of it, whether by working in science, supporting technology, or inspiring others through art and storytelling. The story of space is also the story of humanity's creativity, from designing spacecraft to imagining what life on other worlds might be like. These visions help guide our choices and prepare us for challenges we cannot yet see. Exploration will also require us to adapt our laws, ethics, and ways of living, right now. Treaties like the Outer Space Treaty guide how nations use and protect space, but as human activity expands, new rules will be needed. How do we share resources on another planet? How do we protect places of scientific or cultural importance? How do we ensure that space benefits everyone, not just the powerful? These questions will shape the future as much as rockets and habitats. Space can teach us humility, reminding us that we are small in the vastness of the cosmos. But it can also teach us pride in what we can achieve together. Looking up at the stars, we see both a challenge and an invitation, a reminder that there is always more to learn, more to see, more to do. The Milky Way alone contains hundreds of billions of stars, each with its own planets, and beyond it are trillions of other galaxies. The possibilities are endless. Even if we explored for millions of years, there would still be new horizons waiting. This endlessness is not discouraging, it is inspiring. It means our journey will never truly be over. Every step forward will open new paths. Every discovery will lead to more questions. Just as the first people to cross oceans could not have imagined all the lands and cultures they would find, we cannot imagine all that the universe holds. That is why exploration matters, not only for what we gain but for what it makes of us. It pushes us to grow, to think beyond ourselves, and to pass on a vision of the future that is larger than any one lifetime. When we look back from some distant world at the small blue dot where we began, we will see not just a planet but a history of courage, curiosity, and hope. And when we look forward, we will know that the story is still being written, and that we are the authors. The story we are writing now will be remembered by those who come after us, just as we remember the first humans who looked up at the stars and wondered. Our choices today will shape whether the future sees us as careful stewards or reckless exploiters, as explorers with vision or as short-sighted opportunists. Space gives us the chance to define what kind of species we want to be. The vastness of the universe makes it easy to think our actions do not matter, but they do. Every satellite we launch, every planet we explore, every agreement we make will leave its mark on the history of exploration. This responsibility is both a burden and a gift, a reminder that while we are small, we are not powerless. Our tools, our science, and our imagination allow us to change our future in ways no other species on Earth has ever done. But with that power comes the need for restraint. Some places in space may be better left untouched, preserved for their beauty, their scientific value, or the life they may hold. Other places will call to us to settle, to build, to make new homes. The art will be in knowing the difference. Learning to live in balance with our surroundings on Earth will prepare us to do the same beyond it. Space also offers a mirror, showing us our own nature. It reveals our ingenuity, our courage, and our longing to explore, but it also reveals our capacity for conflict, short-term thinking, and carelessness. If we can face these truths honestly, we can carry forward the best of what we are. The journey ahead will not always be smooth. There will be failures, losses, and moments when it seems the dream is too far, but history shows that persistence is one of humanity's greatest strengths. We build on each other's work, learn from each setback, and move forward again. That is how we crossed continents, how we flew, how we reached the moon, and how we will one day travel beyond the solar system. The next great explorers may not look like the astronauts of today. They may be born on Mars, grow up in rotating space habitats, or live their entire lives aboard starships. They will inherit our achievements and our mistakes, and they will carry the story further than we can imagine. When they look back, they will see this time, our time, as the dawn of something new, the moment when a single planet species began to take its first steps into the ocean of stars, and perhaps, far in the future, when we have spread to many worlds, we will look back together at that tiny blue dot and remember that it was here, on Earth, that the journey began. That tiny blue dot will always be our first home, no matter how far we travel. It is the place where life began, where our species learned to walk, to think, to dream, and to look beyond the horizon. Even if one day we live among many stars, Earth will be the root of our story, the light of its sun, the pull of its gravity, and the memory of its landscapes will be part of us. The oceans, forests, mountains, and skies of Earth have shaped our bodies and our minds. They have given us the tools to survive, the stories to inspire us, and the connections that bind us together. Leaving Earth will not erase those ties. It will make them more precious. Distance has a way of deepening appreciation. Just as travelers cherish the home they leave behind, future generations among the stars may see Earth as a place of pilgrimage, returning to walk where their ancestors once walked, to stand on the shores where ships first sailed, to look at the night sky from the planet where humanity first looked up and wondered. That connection will remind them of how far we have come. It will also remind them of what we must protect. Earth is fragile, and it will always need care, the same skills we use to keep ourselves alive in space, managing resources, recycling, adapting to harsh environments, can help us preserve our home world. The challenges of living beyond Earth will teach us resilience and cooperation, qualities that will serve us well in caring for the planet that gave us life. In this way, space exploration and Earth stewardship are not separate goals. They are parts of the same mission, to ensure the survival and flourishing of life. As we step into the wider universe, we must carry with us not only the desire to explore but also the wisdom to protect. Our future among the stars will be brighter if we remember the lessons of our first home. In time, humanity may grow so widespread that the idea of a single shared identity seems distant. Cultures, languages, and traditions may evolve in ways we cannot imagine, but the knowledge of our common origin can remain, a thread connecting all human worlds. No matter how different our descendants become, they will all be children of Earth. They will all share a story that began on a small blue planet, orbiting a yellow star in one arm of the Milky Way. And perhaps, when they look back from the edge of the galaxy or from another galaxy entirely, they will see that dot in the distance and feel what we feel now, a mix of wonder, humility, and gratitude, knowing that everything they are began there. And so the story comes full circle, beginning and ending with that small blue world. The journey into space is not about leaving Earth behind, but about carrying it with us wherever we go. Every step into the unknown will be guided by the lessons we learned here: how to adapt, how to cooperate, how to hope. Our science will give us the means to survive. Our creativity will help us imagine new possibilities. And our compassion will remind us why survival matters, in the vastness of the universe. It is easy to feel insignificant, but the truth is that our existence is rare and precious. Life, as far as we know, is uncommon. An intelligent life capable of understanding its place in the cosmos is rarer still. That rarity gives our actions meaning. It means that what we choose to do with our time in the universe matters. We can use it to build, to explore, to learn, and to connect. The first explorers of the seas could not have imagined satellites orbiting distant planets, and we cannot. Imagine all that the future holds. There will be discoveries that change everything we think we know, wonders that challenge our understanding, and challenges that test our resolve. But if we face them with curiosity and courage, we can create a future that honors both our past and our potential. One day, perhaps, we will look back from a world circling another sun, or from a ship sailing between the stars, and we will see Earth not only as our birthplace but as the foundation of a civilization that embraced the universe. We will see the long chain of steps that brought us there, the first fire, the first wheel, the first rocket, the first footprint on another world, and we will know that each one was part of the same journey. The stars will no longer be distant lights in the night sky but places we have touched, explored, and made our own. And yet, no matter how far we go, the sight of Earth will still stir something deep within us. A reminder of where the journey began. That feeling will bind us together across time and space, linking all who came before with all who will come after. This is the promise of exploration, not just to expand our reach but to deepen our connection, to each other, to our home, and to the universe itself. The story of humanity is still being written, and the next chapters are ours to create. If we choose wisely, they will be filled with wonder, discovery, and a sense of belonging that stretches from the smallest grain of sand to the farthest star.